Alright, today what we're going to do is look at a few problems from 11.4 that have come in. Some questions have come in about these problems. And the first one is 14b. So I'm going to show that right here. This is 14b from your textbook. And you know that the problems in your WebAssign are reflections of the problems you do from the textbook and vice versa. So we're going to look at this. So in this particular problem, if we read it, it just says find the volume of each pyramid. Now remember, the volume is equal to the area of the base. And the big B stands for whatever shape the base is, that's the formula you're going to use and find the area, times the height of that prism or the pyramid. So in this particular one, we also have to remember that it is a pyramid, and the volume will be 1/3 of that, because it's based on being 1/3 the area of the actual triangular prism. So what we're going to do now is we'll say, okay, well that's 1/3, and the area of the base. And the part about this is you need the area of the base. Since it's a triangle, the formula is 1/2 the base of that triangle times the height. Now notice I'm using a little b here because I'm just talking about the base of the triangle. So, and then still times the height of that pyramid. So it's going to be 1/3 of 1/2. Now, you're saying, what is the base and what is the height? There's nothing like on this front face. If you look at just this front face right here that we're looking at, it has, through the center, it has a height, but it doesn't have the face height. What we're doing is we're trying to find the height of, and I hate to write on this, but we're trying to find the height of this triangle because we're trying to find its area. Here's the deal. That is a right angle. So I'm going to transcribe that right angle. It has a leg that is 5 feet by a leg that is 6 feet right there at that right angle. So there's your base being transcribed onto the paper. Do you see it? Alright, so the base then, in this particular, I could roll it over and the base would be 6 and the height would be 5. Or I could leave it at this shape and the base is 5 and the height is 6. But the deal is 6 times 5 or 5 times 6 is still going to be 30. So I have a base of 5 and a height of 6. Times the height of the whole pyramid. And this middle thing right here is the 7 feet. So it is 1/3 of 1/2 of 5 times 6 is 30, so that would be 15 times the 7. Okay, so let's put this in. That's 15 times 7 is 105, and then you're taking 1/3 of that, which would be divided by 3. So it is equal to 35. Now remember, this was feet, and feet times feet times feet is cubic feet. Volume is cubic. So 35 cubic feet. Okay? Why is it 1/3? Because remember in the study that we found that within the, let me find one to explain it. If I were to take a regular, it would take 3. I would fill this up 3 times. It would take 3 of these filled up of volume to fill this volume. So we know that this is length times width times height. The base is length times width, so now we've changed it. So this would be 1/3 of the area of that pyramid, because this pyramid takes up 1/3 of that volume. That's where the 1/3 comes from. So this is a great, if you're teaching, you remember you're taking math for teachers, so this is a great volume exercise. Is have some rice one day in your class and have your shapes and let them fill this up and realize that it takes 3 of these, and then you can transpose then that this is 1/3 the volume of this. And I'm going to close the door, so I'm going to walk away. We've got to play, so hang on just a moment. I'm sorry I had to walk away. We have a lot of high schoolers coming in for the Lauderdale County play, high school play. Alright, so that would be how you do that problem. Now, let's look at number 28. Okay, so number 28 and 30. Now, number 28, most of you do fine on just finding the volume of this particular gas tank. I'll go ahead and start with that. So, on number 28 of the gas tank, volume of a rectangular prism is length times width times height. So, this particular volume has a width of 18, I'd say a length, either one of them. They're all being multiplied. We know the height is 14, so we're going to say it has a length of 24. I'm going to convert that to a decimal. 0.5 times a width of 18 times a height of 14. Now these are all inches, so when I get my answer and I put that in, I have 24.5 times the 18 times the 14. I get 6,174, and these are inches times inches times inches, so that's inches cubed, which volume again, remember, is cubic. Alright, now the B part. The B says, how many inches high is the fuel level when the tank contains 21 gallons? So when we're talking about this, let me just get, I don't have a pencil. Do you have a pencil? What I'm trying, without writing on this textbook page that's permanent, is I want you to realize something. I want you to see that in this particular thing, the whole thing holds 6,174 cubic inches. Now the first thing they're going to say is that how full will it be. So we're going to assume it's not going to be full all the way. They just want to know how full will it be if you have 21 gallons in there. So if you can imagine 21 gallons filling it up, it's not going to be all the way filled up is what we're assuming. Well, we have first got to get these in the same units. I'm going from cubic inches, now I'm talking gallons. So in the problem on your WebAssign, and right here they give me my conversion. 1 gallon of gasoline has a volume of 231 cubic inches. So I either have to change the cubic inches to gallons, or I have to change the 21 gallons to cubic inches. I'm going to change the 21 gallons to cubic inches because I've got my dimensions in inches, I've got my outcome here in cubic inches, so I think I would rather do that. So the first thing I need to do is change 21 gallons to cubic inches, and I know there are 231 cubic inches per gallon. So I'm going to do that. And the way you do conversions, you write down what you do have, which I have 21 gallons. And then it tells me there are 231 cubic inches per gallon. Now I want the gallons to cancel, so I'm going to say 1 gallon down here to 231 inches cubed. Okay? Now that's just multiplying. What that's really doing is you're saying 21 times my conversion rate of 231 per inches cubed per gallon. The reason I do it this way is kind of the chemistry way I learned in high school. It actually has a name, which I cannot remember, of doing it this way. And so when you go across, your answer is to say, well, 21 times 231 inches cubed. And if you notice, you're going to be dividing by 1, so that's just not anything to worry about. Okay, so I have 21 times, times 231 equals 4,851 cubic inches. So that equals 4,851 cubic inches. Alright, so that's good because that tells me here's this tank and I've got 4,000 something and a 6,000 something volume. So it's not overflowing, is it? It's not full. There's going to be a space. Now, here's where we got to answer the question. B part says, how many inches high is the fuel level when the tank contains 21 gallons of gas? I'm going to change that. How many inches high is the fuel level when the tank contains 4,851 cubic inches of gasoline? Okay, all it is that's what 21 gallons represent. Alright, well let's think about this. My volume of the gallons, this is the volume of gasoline that I've got in there. So my volume is equal to length times width times height, and I have 4,851 cubic inches. The question is, how high is it inside of there? So that's what I'm looking for. And you say, well, hey, wait just a minute. What is my length and width? I can't figure the height with this volume without the length and width. Well, am I not putting it in the same container? Does it not have the same, is it going to fill it with the same length and width? So what is my length? 24.5. What is my width? 18. And I will see how high it fills it up. Does that make sense? So my answer will be 4,851. Let me clear this. 24.5 times 18 is 441 H, and now I'm just divide by 441 both sides. So H is equal to 4851 divided by 441, 11. It's going to fill it up 11 inches high. So let's look at my picture again. Okay, so it's 14 inches to here, and it's going to fill it up to 11 inches. So that's how much high it's going to fill it. Does that make sense? Mm-hmm. Wasn't that kind of fun? So the next one we have, I think about, y'all, I make all, did you hear that, y'all? So here I am making a video, and I'm using my southern, y'all. But I was the cake maker in my class. And if you think about a cake and you put icing on it, doesn't that make a height of icing around that? So you're going to have a height of icing around it. So if it's a rectangle, and let's say I put some icing on top of it, it's going to extend the width of the cake and the height of the cake. Isn't it doing all of that all around it? So coming down, there's a cake. So you've got this thin, what I'm saying is on top, you've got this thin layer of icing on top. And you've got a thin layer of icing around the bottom, or around the sides, that are on that cake. Okay? So what we're looking at, when we look at number 30, the story with number 30 is that 1 cup of frosting, let's write this down, 1 cup of frosting is approximately 14 cubic inches of coverage. I mean, 1 cup is about 14 cubic inches. So that's the volume, that's a volume. Volume is how we measure, we dip out a cup of icing, and that's its coverage in volume. It'll cover 14 cubic inches. Okay. Our 2 cups, the question are 2 cups of frosting enough to cover the tops? I guess I would have put 2 cups of frosting enough to cover tops and sides. Top and sides of this cake. Alright, if I cover it at a thickness of 1/8 of an inch all the way around. So what they're saying, I'm going to put a layer of frosting on top that is 1/8 inch thick. I'm going to put a layer of frosting on top, on the side, that is 1/8 thick. And I'm going to put a layer of frosting on the other side that is 1/8 inch thick. Okay? So when I go to do this, my cake, that just does not, they cut off, I'm not real professional, but that looks like they do professional where you make it flat, they cut off the top of the cake. So just the top of the cake, we're just going to talk about the top. I'm going to layer icing on there with 1/8 inch. But now what is the length of this cake? Icing right here. What is this length? It's the 9 right here. Now I'm going to extend that icing all the way over on top of that cake. So I've got a length, and what's the width of this icing? 9. Now does it affect this 3 over here? I'm just putting the cake on this top layer. So all I'm looking at is layering 1/8 of an inch. So it's like, here's my cake, and I'm putting this dimension of icing on top of it. So notice it's going to have the same length and width of icing, but it's going to have this 1/8 height of icing. So that becomes my volume of icing on the top. Does that make sense? So to figure the amount of volume of icing, this is in inches, and I'm doing an 1/8 height. So the top will be a 9 by 9 by 1/8 inch height of icing. Alright, now let's cut this apart again. Now let's just look at the side of this cake. And I'm not going to look, I'm just going to cut that, and I'm going to put on that side, I'm going to lay it like that, but I'm going to layer an 1/8 of inch of icing on it. So that 1/8 of inch icing is going to be sitting on it, sort of like what we do. Make a better picture. Here's the side laying down, and I'm going to layer an 1/8 of inch, you see, of icing on top of it. Okay, what is its length and width? So here's the side. We're just looking at the side. What is this width right here? The 3 by 9 rectangle is what I'm putting icing on. So 3 times 9 is the length and width of the icing I'm putting on top, times the 1/8 inch thickness or height. Now, is this side on the left going to be the same? Yes. So it's another 3 by 9 by 1/8. Oh yes, very good. So I got one side. Now what is this side? Is it the same? It is going to be 9 by 3 also. So we got 2 more, the front and the back. So we got the 2 sides, the front, the back, and the top. But not the bottom. Do you ice the bottom of a cake? No. Alright, so really, how many sets of these do I have? 4. So I got 4 sets of 3 by 9 by 1/8, plus the top 9 by 9 by 1/8. And so I can put that in my calculator. So I have 4 open parentheses. I'm just going to do it just the short-term way I can. And in that parenthesis is 3 times 9 times, and then I'm going to say 1/8, and then close that. Now remember, on a calculator, for every open there is a close. I opened the big one, but inside I had a 1/8. Alright, I'm going to hit enter. That's 13.5 plus the answer of 9 times, in parentheses, 1/8, and then close that. And I get 23.625 cubic inches. Now the question is, it said, are 2 cups. Now 1 cup is 14, so if they had said 1 cup, I wouldn't have enough. I need 23 cubic inches. But what would 2 cups be? If there's 14 per cubic inch, would be 28, right? So 2 cups, based on this, right here, 2 cups would equal 28 cubic inches. I need 23, so the answer is yes, because 28 cubic inches is more than 23 cubic inches. So I hope that's been helpful. I'm going to post this. You'll see it posted in Canvas, and I will be sending out an inbox to let you know that you will have a video covering this.